Hello everyone, welcome to another episode of Deep Dive Knowledge Talk. Greetings readers. It's my pleasure to introduce you to a fascinating discussion on the intricate world of oil and gas exploration and production. Today, I'm joined by a leading expert in the field who will shed light on the key concepts and recent advancements in this vital industry. Our first question delves into the initial steps of the exploration process. Could you elaborate on the role of geological assessments and seismic surveys in identifying potential hydrocarbon reserves?
In the early stages of oil and gas exploration, geologists meticulously examine existing geological maps and conduct aerial surveys to pinpoint areas with promising geological formations. These formations, such as faults or anticlines, often indicate the presence of hydrocarbon-bearing rocks. To gather more detailed information, geologists employ three primary survey methods: magnetic, gravimetric, and seismic surveys. Imagine the magnetic survey as a detective using a metal detector to uncover hidden magnetic variations in the rocks below the Earth's surface. These variations provide clues about the types of rocks present. The gravimetric survey, on the other hand, resembles a delicate scale that measures tiny changes in the gravitational pull at the Earth's surface. These subtle variations can reveal the presence of denser rocks, which may indicate the existence of hydrocarbon reservoirs. Finally, the seismic survey is akin to an ultrasound for the Earth. Geologists send sound waves deep into the ground and analyze the echoes that bounce back. By studying these echoes, they can create detailed images of the underground rock formations and identify potential hydrocarbon traps.
Thank you for providing a thorough overview of the geological assessments and seismic surveys used in the early stages of oil and gas exploration. Now, let's delve deeper into the next crucial step: exploratory drilling. Could you elaborate on its significance and explain how it helps confirm the presence and quantity of hydrocarbon reserves?
Exploration drilling is a crucial step in finding out if there are hydrocarbons in the ground and how much of it is there. It involves drilling a hole into the earth to collect samples of rocks and fluids. These samples are then analyzed to determine the presence and quantity of hydrocarbons. Just like when you are looking for something you lost in your room, you might look under the bed, in the closet, and other places where it could be. Exploration drilling is like that, but instead of looking for a lost toy, we are looking for hydrocarbons. By drilling in different locations, we can get a better idea of where the hydrocarbons are and how much there is.
Thank you for explaining the significance of exploratory drilling. Now, let's move on to the next phase: appraisal drilling. Could you describe its purpose and how it helps determine the size and extent of a hydrocarbon reservoir?
Appraisal drilling is the next stage of exploration after a discovery. Well has been drilled and hydrocarbons have been found. The purpose of appraisal drilling is to determine the size and extent of the hydrocarbon reservoir. This is done by drilling additional wells around the discovery well to map the reservoir and to collect data on the reservoir's properties, such as porosity, permeability, and fluid saturation. The data collected from appraisal drilling is used to create a reservoir model. This model is used to estimate the amount of hydrocarbons that can be recovered from the reservoir and to plan the development of the field.
Thank you for shedding light on the role of appraisal drilling in evaluating hydrocarbon reservoirs. Now, could you elaborate on the techniques employed in appraisal drilling to gather crucial data about the reservoir's properties, such as porosity, permeability, and fluid saturation?
In order to collect important data about reservoir properties such as porosity, permeability, and fluid saturation, a technique called wireline logging is used in evaluation while drilling. It involves lowering a long, thin instrument called a wireline into the wellbore. The wireline carries various sensors that measure different properties of the rock formations as it passes through them. These sensors can measure electrical conductivity, natural radioactivity, and other properties that provide valuable information about the reservoir's characteristics. The data collected from wireline logging helps geologists and engineers to better understand the reservoir and make informed decisions about how to extract the oil and gas.
Thank you for introducing wireline logging as a technique for gathering crucial data about reservoir properties. Could you further explain how the data from wireline logging is processed and interpreted to provide valuable information about the reservoir and its characteristics?
The data collected by the wireline logging technique is processed and interpreted to extract valuable information about the reservoir and its properties. This process typically involves several steps. 1. Data acquisition. The first step is to acquire the data using the wireline logging tool. The tool is lowered into the wellbore, and sensors measure various physical properties of the formation, such as electrical conductivity, density, and porosity. Now, data processing. The raw data collected from the wireline logging tool is then processed to remove noise and other artifacts. This processing may involve filtering, smoothing, and calibration. 3. Data interpretation. The processed data is then interpreted to determine the properties of the reservoir. This interpretation is typically done by comparing the data to known geological models and by using specialized software. 4. Reservoir characterization. The interpretation of the wireline logging data can provide valuable information about the reservoir, such as its thickness, porosity, permeability, and fluid content. This information is used to characterize the reservoir and to determine its potential for hydrocarbon production.
Thank you for providing detailed insights into the process of acquiring, processing, and interpreting wireline logging data. Could you further elaborate on the significance of these reservoir properties, such as porosity, permeability, and fluid content, in assessing the potential of a reservoir for hydrocarbon production?
To evaluate the potential for hydrocarbon production, it is crucial to understand the properties of the reservoir rock. These properties include porosity, permeability, and fluid saturation. Porosity refers to the amount of open space or voids within the rock that can be occupied by fluids like oil or gas. It is expressed as a percentage of the total rock volume. Higher porosity means more space is available for fluids to reside and flow. Permeability, on the other hand, describes the ability of the rock to allow fluids to flow through it. It depends on the size and connectivity of the pores. Higher permeability enables fluids to move more easily through the rock. Fluid saturation indicates the proportion of pores filled with specific fluids, such as oil, gas, or water. Understanding the fluid saturation helps determine the amount of recoverable hydrocarbons. By analyzing these reservoir properties, geologists and engineers can assess the likelihood of finding and producing hydrocarbons from a particular formation.
Thank you for clarifying the significance of porosity, permeability, and fluid saturation in evaluating a reservoir's potential for hydrocarbon production. Could you further elaborate on the methods used to estimate these properties from wireline logging data?
The wireline logging data is used to create a detailed picture of the reservoir's properties. This data can be used to estimate the porosity, permeability, and fluid saturation of the reservoir. Porosity is a measure of the amount of pore space in the rock. Permeability is a measure of how easily fluids can flow through the rock. Fluid saturation is a measure of the amount of oil, gas, and water in the rock. These properties are important because they affect the amount of oil and gas that can be produced from the reservoir. Porosity and permeability determine how much oil and gas can be stored in the reservoir, and fluid saturation determines how much of the oil and gas can be produced.
Thank you for providing additional insights into the methods used to estimate porosity, permeability, and fluid saturation from wireline logging data. Could you further elaborate on the importance of understanding these properties in the context of hydrocarbon exploration and production?
Understanding the properties of the reservoir rock, the underground pressures, the viscosity of the oil, and the oil-gas ratio is crucial in hydrocarbon exploration and production for several reasons. 1. Reservoir characterization. These properties help geologists and engineers understand the nature of the reservoir, its size, shape, and the distribution of oil and gas within it. This information is essential for planning drilling and production strategies. 2. Drilling optimization. Knowing the properties of the reservoir rock allows engineers to select the appropriate drilling techniques and equipment to efficiently extract oil and gas. Production forecasting. The viscosity of the oil and the oil-gas ratio determine the flow rate of hydrocarbons and help in predicting the production potential of a well. 4. Artificial lift selection. When the natural pressure of the reservoir is insufficient to bring oil and gas to the surface, artificial lift methods such as pumping or gas injection are used. The choice of the most effective method depends on the properties of the reservoir fluids. 5. Reservoir management. Monitoring and understanding these properties over time is essential for managing the reservoir effectively. It helps in optimizing production rates, maximizing recovery, and preventing reservoir damage.
Could you provide further insights into the techniques and methodologies used to determine the underground pressures within a reservoir? Understanding these methods is crucial for evaluating the reservoir's potential and planning efficient production strategies.
Sure, I can explain the techniques and methods used to determine the pressure within an underground reservoir. Understanding these methods is crucial for evaluating the potential of the reservoir and planning an efficient production strategy. One common technique is to use downhole pressure gauges. These gauges are placed directly into the reservoir and measure the pressure at that specific location. This provides a direct and accurate measurement of the reservoir pressure. Another technique is to use wellhead pressure gauges. These gauges measure the pressure at the surface, where the well meets the production equipment. While not as direct as downhole gauges, wellhead pressure gauges can still provide valuable information about the reservoir pressure. In addition to these direct measurement techniques, there are also indirect methods that can be used to estimate reservoir pressure. These methods typically rely on analyzing the production data from the well. By observing the flow rates and pressures at different stages of production, it is possible to infer the reservoir pressure. The choice of which technique to use depends on a number of factors, including the accuracy required, the cost, and the availability of equipment. In some cases, a combination of techniques may be used to get the most accurate results. By understanding the pressure within an underground reservoir, oil and gas companies can make informed decisions about how to produce the hydrocarbons in the most efficient and cost-effective manner.
Thank you for explaining the techniques used to determine underground reservoir pressure. Additionally, could you provide insights into the factors that influence reservoir pressure and its significance in managing the production process?
The reservoir pressure is influenced by several factors, and it is crucial to manage these factors effectively to optimize production processes. One key factor is the natural pressure of the reservoir, which is determined by the depth and composition of the reservoir. As hydrocarbons are extracted, the reservoir pressure tends to decline over time. To maintain optimal production rates and maximize the recovery of oil and gas, various techniques can be employed. One common method is to inject gas, water, or steam into the reservoir. This helps to maintain pressure and enhance the flow of hydrocarbons towards production wells. Additionally, drilling additional injection wells can further support pressure maintenance and improve recovery. Other methods, such as hydraulic fracturing and acid treatment, can also be used to stimulate production. Hydraulic fracturing involves creating fractures in the hydrocarbon-bearing formation to increase permeability and facilitate the flow of oil and gas. Acid treatment, particularly in limestone formations, aims to dissolve and enlarge flow channels, improving hydrocarbon recovery. By understanding and managing the factors that influence reservoir pressure, operators can optimize production processes, increase recovery rates, and extend the lifespan of oil and gas fields.
Thank you for providing insights into the factors influencing reservoir pressure and the techniques used to manage it. Additionally, Could you elaborate on the importance of monitoring reservoir pressure and the potential consequences of neglecting it?
Monitoring reservoir pressure is important because it can help to ensure that the reservoir is producing at its optimum rate and that the reservoir is not being damaged. If reservoir pressure is not monitored, it can lead to a number of problems, including reduced production. If reservoir pressure is too low, the reservoir may not be able to produce at its optimum rate. This can lead to lost revenue and reduced profitability. Damage to the reservoir. If reservoir pressure is too high, it can damage the reservoir. This can lead to reduced production and increased costs. Environmental damage. If reservoir pressure is not monitored, it can lead to environmental damage. This can include the release of harmful gases and the contamination of groundwater.
Thank you all for joining us today. In this episode, we've explored the intricate processes involved in exploring and extracting hydrocarbons from the earth. We've learned about the critical steps of geological assessment, seismic surveys, exploratory drilling, and appraisal drilling, each playing a vital role in identifying potential hydrocarbon reservoirs and determining their size and extent. We've also highlighted the significance of wireline logging as a technique for gathering crucial data about reservoir properties. This information is essential for characterizing the reservoir, estimating hydrocarbon volumes, and making informed decisions about extraction strategies. We've also discussed the importance of understanding reservoir pressure, which influences production rates and recovery efficiency. Various techniques can be employed to maintain optimal pressure and enhance the flow of hydrocarbons. Regular monitoring of reservoir pressure is crucial to ensure optimal production rates, prevent reservoir damage, and minimize environmental risks. By comprehending and managing the factors that affect reservoir pressure, operators can extend the lifespan of oil and gas fields while maximizing recovery. Thank you again for joining us. We hope you found this discussion informative and engaging.